The lesson for today is double and half angle trigonometric identities. The first thing I'm going to do is derive these using the sum and difference identities. So you can write these down or just watch the derivations, that's up to you. Starting with sine 2 theta. This literally means that we're taking an angle and we are doubling it and finding the sine value. This doesn't mean that we're going to double the value. I can rewrite this as sine, or we're not doubling the sine value. So sine of theta plus theta, that's going to be equal to sine of 2 theta. I can then apply the sum rule for sine. So that's going to be sine of theta cosine theta plus sine of theta cosine theta, which when we simplify this, since these are the same, is going to be 2 sine of theta cosine of theta. Next is cosine. Well, that's going to equal cosine of theta plus theta. So applying the sum rule for cosine, that's going to be cosine theta cosine theta. This is plus, this is minus sine of theta sine of theta. So we're going to have cosine squared theta minus sine squared theta. Okay, and this is different than the sum. If this was a plus, then it equals 1, but if it's cosine squared minus sine squared, it is the double angle identity for cosine. We do have two variations of this one, and that's if we solve this for sine or solve this for cosine. Okay, so I'm going to take this cosine and replace it with 1 minus sine squared. Okay, that's going to simplify to 1 minus 2 sine squared theta. I'm going to do the same thing here. Minus, instead of sine, I'm going to replace that with 1 minus cosine. So it's going to be cosine minus negative is 2 cosine squared theta minus 1. So we're going to add these to our identity worksheet. So we're going to add our double angle identities. Sine 2 theta is going to equal 2 sine theta cosine theta. Cosine 2 theta is cosine squared theta minus sine squared theta. And then I'm going to put the two variations. It's 2 cosine squared theta minus 1, or 1 minus 2 sine squared theta. We'll go ahead and add tangent as well. But again, just like with the sum and difference, we don't tend to use the tangent one as often. So this is going to be 2 tangent theta over 1 minus tangent squared theta. Alright, so now we're going to use these identities. If sine theta equals 3/4, and theta is between 90 and 180, we're going to find sine 2 theta, cosine 2 theta, and tangent 2 theta. So I'm going to start by writing out the identity. That's going to be 2 sine theta cosine theta. I have sine of theta. I do not have cosine of theta. So we're going back to our triangles. So I'm going to make a triangle for theta. Okay, sine is 3/4, so that means the opposite side is 3. My hypotenuse is 4. This is not a 3, 4, 5 triangle since the hypotenuse is not 5. So 3 squared plus x squared equals 16 is equal to 4 squared, which is 16. 16 minus 9 is 7. So x is the square root of 7, which means cosine of theta is going to be root 7 over 4, but since we're between 90 and 180, that's the second quadrant, it's going to be a negative root 7 over 4. So now we have those values that we can plug in to our identity. So 2 times 3/4 times negative root 7 over 4. So this will be 2 times 3 is 6, so we're going to have a negative 6 root 7 over 16, which simplifies to negative 3 root 7 over 8. Cosine 2 theta is going to be cosine squared theta minus sine squared theta, or you could use one of the variations if you wanted to. Cosine of theta is negative root 7 over 4. We're going to square that. Minus 3 over 4 squared. That's going to give me a positive 7/16 minus 9/16, which is going to be negative 2/16, which is negative 1/8. For tangent, I'm simply going to use the previous two answers and divide them, because tangent sine over cosine, so that's going to be negative 3 root 7 over 8 over negative 1/8. Well, they have the same denominator, so those go away. Negative over negative is positive. 3 root 7 over 1 is just 3 root 7. If theta was between 90 and 180, that means if I doubled it, it's going to be somewhere between 180 and 360. So it's either in the second or the third or fourth quadrant. But since both the sine and cosine are negative, we know it's in the third quadrant. Okay, so we are going to verify that 1 minus cosine 2x secant squared x equals tangent squared x. So the first thing we're going to do is replace this with the double angle identity for cosine. You can do any of them, but I tend to just use the first one, and then if I need to solve, I can. So I'm going to replace that with cosine squared minus sine squared. We're going to multiply that times secant, which is 1 over cosine. Okay, I'm going to go ahead and distribute this into the parentheses. So I'm going to have 1 minus cosine squared x over cosine squared x minus sine squared x over cosine squared x. Well, cosine over cosine is just 1. Sine squared over cosine squared is tangent squared. So we have 1 minus 1, that goes away, and then minus negative tangent is just tangent squared. So now we're going to use the double angle identities in trig equations. So I've got cosine 2x plus 3 cosine x minus 1 equals 0. Okay, so my first thing automatically when we see this is we need to replace this with the double angled identity for cosine. But we have 3 options here. Okay, I could use this one, I could use this one, or I could use this one. Since that middle thing has a cosine, I'm going to replace it with 2 cosine squared minus 1. Okay, if you had done the first one, which is totally fine, you just have to add a step where you turned the sine squared into a cosine squared, and you'd end up with this anyway. So I have 2 cosine squared x plus 3 cosine of x minus 2 is equal to 0. And we will factor. So we're going to have a 2 cosine and a cosine. To get this negative 2, we've got a 2 and a 1, and then we want to think about how to get that 3. Well, if I multiply this 2 by a positive 2 and this 1 by a negative 1, I'll get that 3. So we have 2 cosine x minus 1 equals 0, or cosine x plus 2 equals 0. So either cosine of x equals 1/2, or cosine of x equals negative 2. Cosine is going to equal positive 1/2 at pi over 3 and 5 pi over 3. Cosine is going to equal negative 2. Never. Okay, our next example, cosine 2x plus sine x equals 1. Okay, again, I'm going to do a double angle identity for cosine. Because of this, I'm going to choose our second variation and replace this with 1 minus 2 sine squared x. Okay, so we're going to move everything to one side. Since this is a minus, I'm going to move it over to this side. So I'm going to add this 2 sine squared, subtract the sine, and subtract 1, which is going to go away. So I'm going to factor out a sine. So either sine of x equals 0, or 2 sine x minus 1 equals 0. Sine is going to be 0 at 0 and pi. Sine is going to be 1/2 at pi over 6 and 5 pi over 6. Our next one, sine 2x plus sine x equals 0. The first thing automatically when you see that is we need to replace it with its identity. So it's going to be a 2 sine x cosine x. Okay, now I can factor out the common factor. So either sine x equals 0, or 2 cosine x plus 1 equals 0. So sine is going to be 0 at 0 and pi, and 2 pi, but we don't include that. And then cosine is going to equal negative 1/2 at 2 pi over 3 and 4 pi over 3. Okay, the last set of identities that we're going to have in this unit are the half-angle identities. The half-angle identities are not as commonly used as the other ones. We use the double-angle identities quite a bit, the basic ones obviously quite a lot, but the half-angles not as much. So I'm going to write these down. So these are the half-angle identities. You might want to pause and jot them down. So now we're going to use the half-angle identity. We're going to use the half-angle identity to find the exact value. Our first one is going to be sine of 15. Okay. We could use the sum and difference identities to find this by rewriting this as like 45 minus 30, or we can use the half-angle identity. Okay, to use the half-angle identity, we need to get it into this format. So we want sum theta over 2. And I'll talk about the plus or minus here in a minute. So this is going to equal sine of 30 over 2. Okay, so I'm just changing the 15. So now in my equation, the theta is going to be 30. The plus or minus, you are going to have to know whether the angle you're talking about is positive or it's negative. 15 is in the first quadrant, which means it's going to be positive. So I'm going to purposely put the plus here. So this is going to be plus, not the minus, then 1 minus cosine of 30 over 2. So this is going to be the square root of 1 minus the cosine of 30 is root 3 over 2. Okay, so this is the value, but we're going to need to do some simplifying. I'm just going to work straight across. First, I'm going to turn this 1 into a 2 over 2. So in the numerator, we're going to have 2 minus root 3 over 4, over 2 over 2, which is going to turn into 2 minus root 3 over 4, because I've got 2, and then I've got the 1/2, and we're dividing by 2. So this will be 2 minus root 3 over 2. So our last example here, in radians, we've got cosine 7 pi over 12. So we're going to rewrite that as something over 2. So when we had the 15 degrees, we made it 30 over 2. So we double this. So if I double 7 pi over 12, that's going to be 14 pi over 12. Which is really going to be 7 pi over 6 over 2. All right, so we're going to use the half angle identity, which means we need to decide whether it's positive or negative. And we're interested in this angle. We're taking the cosine of 7 pi over 12. 7 pi over 12, this would be 0. This would be 6 pi over 12. This would be 12 pi over 12. Okay, so 7 is there in the second quadrant, which makes the cosine value negative. 7 pi over 6 is in the third quadrant, but that's not what we're using to determine positive or negative. We're physically looking at this angle. So it's going to be a negative 1 plus the cosine of 7 pi over 6 over 2. So that's going to be negative 1 minus root 3 over 2 over 2. Okay, so again, we're going to get the common denominator. So this will be 2 minus root 3 over 2 over 2. So this will be negative 2 minus root 3 over 4. And then we can take the square root. So negative 2 minus root 3 all over 2. So that's how we can use double angles and half angle identities.